I'm glad everyone's over here.
It was 11 years back. I was at Qualcomm and I designed and implemented their secure bootloaders, their encryption algorithms, and it's the world's largest deployment of secure boot. Last time I counted, it was 4 billion units, which have my code in it, and it's been 10 years, so that's probably expanded. You know, we've been in the cloud / security, mixture. It's now heating up a lot. Given the cyber attacks, the amount of data that we're putting in the cloud, it's now heating up. But we have that experience. I also went to school specifically for cybersecurity. I went to school at USC. I have a master's in EE computer networks. I'm totally a developer at cloud. I'm first a developer. I also have an MBA in finance and marketing.
So we actually specialize in data security. So we provide developer tools, SDKs, and APIs so that you can build secure cloud applications without having to spend 6-12 months developing that. Not just developing it, you need to develop it, you need to maintain it, and it's extremely easy to get this wrong. So that's kind of what we do. Our focus has been bringing, for example, we're protecting FBI data in Azure, which is unheard of. It's actually the first project where something as sensitive as, it's governed by CJIS, Criminal Justice Information Systems. And people make a lot of noise about HIPAA. HIPAA is actually the easier version of this. So we can actually do CJIS compliance in the public cloud, it's actually the first project doing that. So question, like data breaches, I know this topic is kind of controversial, especially with the word stop written right over there. People will say, can you actually stop data breaches? Well, you can't have perfect security, but what we can do is make sure that it's extremely difficult for somebody to actually get to your data and do damage to your business. So data breaches, we're trying to build secure cloud applications without spending a ton of money or several months or years building perfection, and so that we can focus on the things that make our applications more interesting and what customers will actually pay for. So have you heard of data breaches? A bunch of these pretty large organizations over there. I had to change my slide to add this in the last couple of days. We laugh about this, but it's actually really unfortunate. We know we can do better than what we see over there. So why is this actually happening? We're moving a lot of our data into the cloud. Applications are going into the cloud. In this day and age, when organizations are building cloud applications, or just applications, they're expected to be building secure cloud applications, which are expected to protect their data. But building something like this is time-consuming, difficult, and chances are you will get it wrong on your first attempt. So it's not like these organizations don't have enough funding behind them or don't have enough time, but the intersection of all of this to make it happen, time, expertise, as well as willingness, all of these things are not combining in the right combinations or at the right point of time. So we have heard of data breaches, at least I hope everyone has. This is kind of like the same thing, but it's segmented differently. If you look at this, so I think the most obvious thing is you see a lot of pink, which is, they just plain simply got hacked. What's interesting is inside jobs were, people are 50% of the times concerned about inside jobs, but it's there, it's definitely there. In fact, the Korean credit bureau breach, which was extremely massive, was actually an insider job. But mostly it's just, stuff getting hacked. We have, a few other cases accidentally published. Facebook, for example, there's another one, Uber. Uber accidentally published their connection string into the GitHub repository, public source. So, what do? I mean, stuff happens, right? So there's a full spectrum, there's nobody you're safe. There's medical companies, there's regular companies, there's, traditional, the internet, core internet companies over here, there's IRS, there's government, pretty much anyone and everyone. What's interesting for everyone in this room is either for us, our businesses, or clients, if we serve different clients, is data breaches are expensive. Extremely expensive, actually. And if you look at healthcare, this is kind of not a surprise. The most expensive healthcare breaches are within healthcare itself. A couple of surprises over here, and there's also a couple of stuff that is not surprising. What's not surprising is the fact that healthcare and financial verticals experience the most expensive data breaches. What might be surprising to people is, most of them are, in 200 and above range. Like it starts from 233, and this is for every record that is breached. So one patient or one email address that goes out is going to cost them $233. Multiply that by some of the largest data breaches, and you have yourself a giant problem. Even something as mundane as retail. So this might be, for example, Target, right? Massive data breach. But there's still a certain amount of cost associated with that. And this is, per data item. How's that actually changing over time? And if you look at time, this is 2010, 2014. There's a clear trend. It's just getting more expensive. So all these numbers are just going to get even more, bigger and bigger. This actually doesn't take into account. This is, backward looking. When you have forward looking information, this changes because we're putting more information in, the cloud. And so that's also going to be increasing. This looks at the same idea, which is the fact that it's expensive, but from a different dimension. This looks at the fact that when a data breach happens within an organization, how much is that organization going to suffer? And so, on an average, it starts off with $5 million for one data breach. So if you have multiple, this happens. Some organizations have data breaches every year. That's how much it's going to cost them on an average. So again, that's not a small number. So in terms of, if you have to convince your customers, hey, you need to invest in security, or you need to go and tell your boss, your manager, saying like, hey, we need to think about security more seriously, there's actually a financial business impact of that. And that leads us into this. It's not just a tech issue anymore. So far, we've always been treating it as just tech issue, like, yeah, the developers will figure it out, or the cloud provider will figure it out. It's actually not. It's not a software developer issue. It's not architect. It's not even CIOs. CEOs are getting fired. Target. Greg, pretty awesome. Had no idea about data security, compliance, IT issues. He got fired. So that's Target's president, CEO, and chairman of the board. He got fired for the data breaches. So again, you have the financial numbers. There's things actually change. So makes our job a lot easier because people are taking things more seriously. So again, in terms of going back to your board, your customers, your supervisors, you actually have real information to say like, hey, if you don't do this, stuff might happen. Like we might lose jobs. Like even with the OPM breach, the Office of Personal Management, a ton. Like it's a 10% of the entire U.S. population has this information leaked out. 10%. So definitely more. 1 out of 10. So you can imagine, probably 4 people or 5 people over here have been breached. So this is kind of where, I kind of describe the problem. But we're developers. We need to get stuff done. So I kind of put this as a funny slide. So this is like, thanks, but what can I do about this? So one thing is you can have multi-factor authentication, not necessarily just, our product over here, but any multi-factor authentication will work. Conceptually, multi-factor authentication is the right thing to do. Whether you use ours or someone else's is totally fine. But you need multi-factor authentication. Most of this talk is not going to be focused on authentication. It's going to be actually focused on the data side of things, which switches us into a demo. I'll get to the demo. But the way you want to think of your application is you have some logic that's unique to your business, unique to your customers, that's going to be sandwiched in between protection from the front end as well as protection from the back end. Because data breaches, a lot of times, it's not that they're always coming from the front end. They might actually come, they might get credentials, but then they just go to the actual databases and basically do SQL dumps or something along those lines. So you conceptually want to think of it as a sandwich. I'm going to protect my front end, use multi-factor authentication, use firewall rules, use whatever you can. But then also focus on data security as such. And so I'm going to switch gears to Visual Studio. This is an example application which I'm going to be using to demonstrate what we're doing. We call it Cloud Medic. And the idea is, this needs to be HIPAA compliant. So there's a lot of other things. And I do want to mention a quick thing about HIPAA compliance. HIPAA compliance deals with every single thing. Like, not just the data portion of it, like, okay, how do my bits flow over my network, my application. But it's also concerned with like, hey, if you hire someone, you're not going to hire them off the street. If you print, this is the way you're going to be printing. So there's a lot of other things that come with HIPAA. So when your customer needs to be HIPAA compliant, you need to make them aware, like, okay, there's a lot of other things. This actually covers the most difficult portion, which is, the data privacy portion of it. And what we'll do is, this is just all the humans inside the system. There's a bunch of different roles. There's my phone. There's nurses, there's physicians, there's patients. Actually, the most important people in any healthcare system. There's physicians, and this is fictitious data, so I can definitely display it without getting into anyone's trouble. And then we have a sysadmin, just kind of created. And the way this is currently structured, this should be really familiar to most people in this room. Let me get rid of. I'm actually going to stop this and kind of show you what it is. This is a generic, MVC application. So you kind of just start off with the template. You create your data model, and let me just bring up. If I can expand this guy. I'm actually able to get something. So this is your standard identity user. Whenever you scaffold a generic MVC application, this kind of fills out with it. We've added some additional information over here, like first name, last name, gender, date of birth, specialty, because you might have a physician who specializes in cardiovascular diseases, another one who might be, a general practitioner. But there's basically nothing stupendously different over here. Email, phone, username. What's interesting is all of this information is still personal identifiable information. You do need to protect it in some particular way. So in a lot of cases when you start building something like this, you're concerned with, okay, like for example, if you want to do data encryption, people most often go and say, okay, I'm just going to switch on transparent data encryption on my SQL server, job done. That was that made a lot of sense 15 years back, 10 years back, when your database server, in fact your whole server farm would be down the hallway inside a server closet, and you want to be a threat model was somebody walking, opening the door, taking out your hard drive and running away with that. TD kind of protects you against that. That is not the threat model you see in the cloud. Nobody's actually going to be doing that unless, I guess it's Mission Impossible or something. Your biggest threat vector for your data in the cloud is hacks and at the logical level. So for example, if somebody is able to do kind of SQL injection or get admin credentials, TDE is not going to help. TDE is just going to decrypt it and hand it over. It doesn't care who you are. You have the right credentials, but you're hacked. Here you go. Kind of say like, you could have the most fanciest encryption algorithm, travels all across the galaxy, comes back, and then you have bits. But from your perspective, I make a request, I get bits. I have no idea what happens behind this. So whether TDE is there or not, it's transparent. And that's actually its weakness in this era of cloud computing. So you might say I'm encrypting stuff, but it doesn't buy you any security. It's an expense without a benefit. So that's just something you need to kind of understand and digest. Now, I'm not saying you don't need encryption. You totally do need encryption, but you need encryption at the right level and for the right kind of information. And that's kind of what I'm going to get at. Is if you kind of look at the database over here. So this is kind of what you would see in your users table. And this is kind of bad. Like at this particular point, you're trusting your SQL server, you're trusting your SQL server admin, and there's a lot of things that would go with it. If you have any legacy applications that connect into the same system, all of them would have this information. And so now suddenly your problem has expanded in scope, where this data is flowing and touching a lot of other resources, human or machine. And now all of a sudden you have to figure out, okay, one sec, Alice has access to this information. I'm gonna have to go make sure, talk to Alice's boss about access controls and all of these other things. So your problem is actually expanding the more systems you're touching. And so what we've actually done is, we're not saying like, hey, don't go to the cloud. That's that's a stupid trend. We don't want to go against, it's like swimming upstream. The cloud is coming, people are going to be expanding into the cloud, so we're like, okay, one sec, we can't run away from it, let's adopt it. What's a good way of adopting this without screwing up our budget, without screwing up our time? The big thing about being in the cloud is you get some really great benefits, like the economics are awesome. You don't have to spend time maintaining VMs or even platform as a service, which is awesome. I don't know how many of you guys have used platform as a service. Extraordinarily more productive than infrastructure as a service. But you give up something over there. Every time you use something like platform as a service, you give up control. You give up the fact that you don't know who's actually administering your systems. So if you're using, I don't know, say Amazon RDS or Azure SQL, all of that is being provided by Microsoft, which is awesome. But then you have no idea if Microsoft is sub-licensing that into some other organization. More importantly, when you have to go and make a claim, like I know who's touching those systems, you can no longer make that claim because you don't actually know who's administering and protecting those systems. So you actually don't want to get into this thing where you want to secure resource 1, resource 2, resource 3, resource 4, because you don't know what's behind those resources. So if you want to invert that model, let me flip things a bit. I'm actually not going to use Git. I'm going to type in that code. So this is kind of what you see. Now, what I'm telling you is we can change this whole security model and make this HIPAA compliant in 60 seconds, and you're going to watch me do it. So let's go back to the actual thing, and let's just go from the top and say, okay, this is my app. In my line of business, I will say, first name is identifiable. So I want to secure that. Is last name? Yeah, I think last name is also something I do want to secure. What else? Gender, I want to secure that too. Date of birth, yes. Specialty, maybe. Let's go. Email, maybe, yeah. I mean, if I have an email address like johndoe@gmail.com, that leaks information about that person. Username, yeah, I think that's also important. So let's do that. Phone number, definitely identifiable. So I'm going to say, well, in my system, that's what's kind of important. So let's kind of do that, and we've kind of expressed everything, and once we're done with this, I'll kind of show what actually happens behind the scenes, how everything kind of manages itself. Now what this is actually doing is, this is following code first, so it's kind of going through.
It's using Entity Framework?
It's using Entity Framework code first, so which is why I was able to just change. But you kind of solve the process. I basically take a step away. Well, in this particular case, it was pretty straightforward for me. I was like, okay, I know the exact pieces of information I need. And there's actually a mixture of business and development decision, which is, for my line of business, what is critical, what is sensitive data. Because you need to know what you have before you can protect it. Everything that we said, we want to protect, and there's actually more information. I'm not surfacing every attribute of the patient that we just protected. Let's also do.
Here's a question for you. Could you turn those all into like X's instead of having gibberish on the screen? Because when you look at that, let's say you're a user and you don't need to know all that information. You wouldn't want to see that gibberish. You just want to see X's across the screen.
What you're describing, so I get what you're saying, and what you're actually describing is a presentation problem.
Okay.
Given that I have this data, how do I want to present it?
Right.
And that's, let's leave that for the designers,
okay.
or so on and so forth. I'm kind of surfacing that just to show you that even in my database, this information is undecipherable. Yeah, so even if you did something like Uber, you check in your connection string, big deal. Your data is still private, and that's kind of the important thing. So this is, the data as it goes through, in this particular case, our security pipeline, and the key management all happens behind the scenes. So there's actually key management some kind of access control list, verification against all of that. But all of that happened just by me, adding that secure prefix on our dashboard. But eventually it's going to be a NuGet package. There's actually a NuGet presentation this weekend, so we're going to be making into a NuGet package. The agent lives right next to you, and then there's an app secret which you'll pick from, again, our dashboard, and you plug that in. And honestly, this one line is all you need to get in, that one line as well as the agent. With these two portions, you have your entire data security available. And at that particular point, you've done the configuration. And again, I didn't type this, but that's just a copy paste. So I'm guessing, you could add 10 more seconds to that. The idea is no one kind of gets left behind. Because, for example, look at Anthem, right? Anthem is a large corporation. When the data breach happened and people were talking to them how it can be done, the common idea was, we know we should be doing it, but it's too hard to do it because we don't have the time to do it, especially the time to do it correctly. Because if you do things incorrectly, for example, transparent, I always go back to TDE. There was a very good reason why Microsoft did not have TDE in the first version of Azure SQL, because who are you protecting against? Like, what threat model are you actually trying to protect against? But there was a lot of customer inertia, which is like, hey, we need TDE, and eventually, they plug that in. But it's more as a response to what people are asking than in terms of bringing real data security. And if I had this system live before, I would have just shared the the SQL connection string with you guys and tried to do whatever you can. I think the worst that you would be able to do is drop the table. But at no point in time would I have my customer or my patient privacy at risk. And that is the key thing. And that is the point at which there's a big club on my head based when that club says HIPAA or PCI or any of these other regulatory standards. Or in case of Target, it wasn't actually a compliance standard, it was just like massive business risk. There's another thing which I didn't actually mention is if you encrypt your data legally, you are not liable for negligence. Yeah, it's negligence is a regular thing, but they use it very specifically in the legal spectrum. So if you just say like, okay, I'm going to do this, I'm going to enable some other form of TDE, you say, okay, I'm just going to put a firewall around this, and I'm still going to leave my data in the clear. You might come up with build your own security model, but you can actually get sued for negligence, and at that particular point, whatever your damages are would be 3 times that. So that is also a very important thing. It's not just the financial impact. You can actually get sued for a lot of different reasons. So this is just the whole idea was I spent half my time telling you about stuff, but then there's got to be a lot of questions, hopefully, in what you guys might have. So,
how secure is my application if the app secret gets somehow leaked, right? It's the same
great
thing,
question.
right?
Great question. And actually, let me switch. I do want to be. Okay, this one actually shows. So this kind of shows your traditional security footprint. When I'm building an application, I have my users, user access devices, network, my actual app data cluster over here. But it's never in isolation. On my system, yeah, I was able to run everything right over here with my database running on the same system. There's a lot, any modern application, especially in the cloud, uses a few other resources. And that's kind of what I'm showing. There's database, there's blob storage, there's file servers, other kinds of servers, maybe queues, a whole lot of other things. And at any point, if you're sending information across those, you now have to trust that particular piece. And not only the actual machine, but also the people behind that. So essentially what happens is your trust footprint keeps expanding. You start using something else, you have to now trust that. This is unmanageable. I mean, this is kind of like the main reason why you have data breaches. It is not because people are stupid. The problem is asymmetric. It doesn't close. The more I use, especially if I'm scaling up, scaling down, there's more instances coming in, or instances are going away and being recycled. This is unmanageable. And what we suggest, and kind of like we live and breathe this. I mean, this is we've actually designed our products to enable this. We say, well, this is unmanageable, so let's pull things together. Let's reduce that trust footprint. You need to trust someone or something. So we end up trusting the application. So what we say is, hey, in this whole spectrum of resources and people, the most sacred people are going to be the developers or the security managers. And the most important piece of software is going to be the application itself. So we might do all this fancy stuff behind the scenes, and then we might come back and say, like, username is John Doe. But if your application goes and sends out a list of all your people in a mailing list or something like that, there's not much we can do. So we can't, I hate to use it, but like we can't protect against stupid. So coming back to your question, like part of putting that app secret in the app itself is because we trust the app. So we don't say like with this system nothing's going to happen. Nothing will ever go wrong. I think the concept of perfect security is asymptotic. You're never going to hit it. The question is, my app has a certain amount of threat models that I'm going to model it against. If your app has a credible threat that it's going to be hacked by the government of China, you have to think differently than the fact that, okay, I just want to make sure, casual, script kiddies aren't going to hack it. By the way, we are being used in federal systems across different countries, so I didn't even make it sound like this wouldn't work in, amplified situations. But you have to think slightly differently. Like in that particular case, can I even trust my developers? If not, then you probably won't have two app secrets, one for development and one for production. And then who makes that switch? Well, you'll have a security manager who does that. If not, then maybe your developers aren't trusted. So you have to think differently. But this makes it manageable, right? All of a sudden, I only have to focus on this.
There's also auditing as well. So you can see if an app secret has been compromised and you can change the app secret.
Yeah, you can also change the app secret, and another feature we're getting is you just want to hit pause. So there's a management dashboard, just like you have an Azure portal dashboard. There's one for us also, and you can just go in and say, I want to actually pause the key manager for this. And at that particular point, anytime you just saw me put the secure attribute in front of individual members. But that is just the expression of a developer saying, I am concerned about this. When that particular entry is consumed anywhere in the full spectrum of data usage, it's actually actively having machine-to-machine communication with a key management server saying, hey, I am acting on behalf of the system administrator or on behalf of a patient, and I want to decrypt this piece of information. Can I get the key? And that goes as a request. There's a full ACL verification against that. Is this permitted? Can we do this? And if yes, then the key comes back. And so you can actually have someone just come in and say, just stop. My app has been compromised. Just stop responding to any kind of key request. So I hope that kind of answers like the trust and what do you do when the trust is compromised.
We also are adding IP verification at some point too. So this is machine to machine. So we'll add a list of white IPs that are whitelisted.
And
for
actually,
GitHub.
what I kind of showed you was the subscription model. As a subscription service as an app secret, we've had some, especially for if you're talking about a nuclear station which is off the grid, which is not at all, and it should not be connected to the public internet. Then there's no way that it can actually talk to our licensing server or a key management server. So then we also have an enterprise stack which is self-contained and sits over there. That does not have an app secret or something like that. So in terms of your app config being leaked, that actually would not be a problem because there's a separate key vault which is also with 2 layers of encryption. But yeah, I mean you still have to kind of treat your application as sacred. We started off from the big, and we kind of zoomed in on. You remember I mentioned about the sandwich approach, which is like my logic is in between. And so this entire presentation was on the back end security of it. You could get hacked from the front, and if you get hacked on the back end, big deal. You have nothing to lose. With this stuff, they can get into your database. He might do SQL dump. Whatever he does, this person, he, she, or an organization
will only have access to CipherDB. So, it's almost like a VPN between LA and New York, and somebody comes in between and, sniffs packets. You don't have to report this. You're not liable for that stuff. It's over a VPN, so it's encrypted to begin with. So at the back end, I think, we totally solved this problem. For the front end, we didn't actually get into that, but a good way of enforcing that is with multi-factor authentication. And then with these two systems, you want to stitch together some kind of information which is, okay, I got hacked. So I think the only thing I would suggest is, and we're actually building that even on a back end, which is, we're trying to analyze the specific pattern of, the key manager's access. So there's a certain way, once you profile an app, the way it does key requests falls into a certain rhythm. And it's different for different apps. And so one thing is anomaly detection based on like, hey, this is how this app has traditionally operated. This is the way it's operating today. I don't know what's going on, but I'm going to send an alert to my CISO or your security manager. That's one way of doing it behind the scenes, and that's one way of finding out when you've been hacked. We're thinking of having that queue end of this year, or maybe later on. We're still trying to figure out. Like, people say that they would like it, but when we ask them, okay, how much would you pay for it? They'll be like, I don't know. So I think it's on our list. We haven't bubbled it up, but you could use the same approach even for front end, which is Gmail does that, right? If it sees, hey, one second, the way this user is now accessing the system, it's kind of weird from the way he's been doing it for the last 6 months. So this doesn't look right. I'm gonna present a second factor that's out there. Sorry, let me actually show you. We actually did some interesting prototype work for an energy company. So we were trying to protect the nuclear station by using this as not just authentication to the cyber systems, but also authentication into the physical systems. So a person would walk in, would drive to the station, and the parking lot door would open once he multi-factor authenticates himself to the parking structure. Once he authenticates himself to the parking structure, he walks in, stands outside the server room, authenticates himself, that door opens. So with every piece, he kind of authenticates himself. And if there's any kind of anomalous behavior, then the system would escalate, saying like, hey, one second. 2 factors, fine. You're acting a little weird, so I'm going to throw in a 3rd factor or 4th factor. And it would do that adjustment dynamically. For example, it would throw in a biometric, or it would also start logging your location, where you were.